Would you like to set up and run a self-hosted Bitcoin Lightning server and connect a mobile wallet so you can use it when you're out and about? Then this guide is for you. Let me warn you that this guide is quite complex. You can follow along by watching this video guide. In this article, we're going to install a build environment, configure an offsite backup environment with Amazon S3, configure PGP for backup encryption, set up a VPN to connect your phone to your Lightning node. We're going to install Core Lightning on testnet 4. We're going to open up our testnet 4 channel, configure testnet 4 backup, and then we're going to configure the Zeus mobile wallet to connect to the Core Lightning on testnet 4. And then we're going to do everything again for mainnet. In a prior article and video, I covered how to build your own Bitcoin solo pool using CK Pool Solo and Bitcoin Knots. You need to have completed installing and have Knots and CK Pool running before following this guide. We are going to be doing two setups, one for mainnet, which uses real Bitcoin, and one for testnet 4. Bitcoin on this network has no value. Testnet 4 is optional and is only used for testing. Testnet 4 is good for experimenting without using actual real Bitcoin. When setting up a Lightning channel, it is recommended that you set the minimum channel capacity to at least 0.01 BTC, which is 1 million sats. In this guide, we will connect to the NiceHash Lightning node, which has a relaxed limit of 0.005 BTC or 500,000 sats. You don't have to be a customer of NiceHash, do KYC, or have a NiceHash login to be able to connect to their Lightning node. You also need a small amount of Bitcoin to pay fees. Consequently, if you follow this guide, you'll need at least 0.006 BTC to send to your Lightning node. Many TCP ports will be created or used. A summary of all the ports is listed below. We will build all the software from scratch. To achieve this, we will create a build environment. So let's start by making sure your Ubuntu system is fully patched. So we'll run the usual sudo apt update. And it's going to prompt me for my privileged password because it's the first time I've used sudo in this session. Once we've done the update, we'll do the upgrade. All right, hopefully I don't have too many packages to upgrade. Yes, I do. All right, we'll just say yes and let them run. All right, let's carry on. So let's install all the dependencies. You will likely already have most of these. Paste all of these lines all in at once. So we'll copy and paste all of this. And then I'll just wait for my previous install to finish. This is something you want to come in regularly doing an apt update, apt upgrade. There is constantly new patches coming out for the Linux system. New features, security updates. It's probably mostly for security updates that we want to keep running the updates all the time. Oh, it's like watching grass grow, isn't it? Okay, now we can run that command to install all of those dependencies. Okay, so that's our build environment done. Creating a backup environment. This section is optional, but unless you don't mind losing Bitcoin, you really should set up a backup environment. 3 key pieces of data secure your Lightning funds. First, the HSM secret. This is a static key and only needs to be backed up once. Number 2, static channel data. This needs to be backed up each time you open up a new channel. And number 3, the database. Detailed information about your funds locked in channels is stored in the database and is only kept on your machine. It's not on the blockchain. This changes with every transaction, and if you lose this, you can lose funds. This needs to be backed up frequently. We will set up an environment that uses offsite backups stored in Amazon S3 in an Amazon S3 bucket. Buckets used for storing files. This should cost less than $10 per year, probably half that. We will also encrypt those backups using PGP. Start by signing up for an Amazon AWS account here. Note that you can sign up for a free 6-month trial account at the time of writing this article. Once you've completed the sign up process, we need to create an access key. This consists of 2 parts, the key ID and a secret. The secret cannot be retrieved once created, so you must store it in a secure location. Click on your account name in the top right hand corner and select security credentials. So that'll be the top right hand corner of the browser, and then you come all the way down to security credentials here. Scroll down to the section labeled access keys and create a new access key. So once you've gone there, you'll come to this page, and down here is the access keys bit, and then this is the button that says create access key. Make sure you save the access key in secret. In the same section, you can add MFA to your account login. You really should do that as well. So you can see there's the MFA, and you can assign an MFA device. We're going to use a cloud service called S3, which provides really cheap cloud storage. In the search bar, which is a bit up the top here, type in S3. And once you've typed in S3, you should see S3 appear here. This is going to be the scalable storage in the cloud. Click on this option. In the top right hand corner next to your name is the region in the world you are currently working in. So remember the count drop down box, that's the region there. I typically select a region that is close to me. Because this is for backups, you might prefer a region on the other side of the planet. Choose a region that makes sense to you. Next to the region name in the drop down box is a region code. So for instance, C for Sydney, the code here is AP-Southeast-2. For example, for Asia Pacific Sydney, the code is AB-Southeast 2. Note this region code down for later. Click Create Bucket. So that's that button right there. You need to generate a globally unique bucket name. I tend to use something that includes my name and the bucket's purpose. For example, pdath-bitcoin-backups. So you can see a bucket I've created there. Choose the default settings for everything. Scroll to the very bottom of the page and select Create Bucket. Back to Ubuntu. The Amazon AWS CLI snap is built to use SE Linux, but Ubuntu uses AppArmor. This doesn't prevent the AWS CLI from working, but it generates many cosmetic warning messages. A clean fix to remove the warning messages is to disable SE Linux. Create the etc. SE Linux config file. So we're going to use VI for this. You might prefer Nano or some other editor. And then copy and paste in this one line. SE Linux equals disabled, and then save that off. And reboot. So you can just go sudo reboot now. I've already done this, so I'll skip the reboot. This is a kernel time parameter. You don't have to reboot right now, but you'll see a lot of warning messages if you don't, which you can ignore. So there's an example of how to do the reboot command. After rebooting, install the AWS CLI snap. So we can just copy and paste that in. Now this is already installed on my system, so I get that warning. Once installed, give it a quick test of this command. So we'll just ask it for what version's installed. And we can see it's currently 2.32.21. This could well be different for you in the future. You should see a line starting with something like, there we go. If you see this, it's working. Now we need to configure the AWS CLI. Run the below and fill in the answers you have recorded before: access key ID, access secret, and region code. When it asks about the default output format, hit return to choose the default. So I won't run this because it'll expose my current key I'm using, but you just simply got to run this and copy and paste in the values. If you run this command, you should see your new bucket. So this is just running it like a directory command. So it says run ls. And this should show all the buckets. We have just one in this account. So there it is there, pdath-bitcoin-backups. Now we have the basics set up for our backup environment. Now that we have an offsite backup system available, we need an encryption system. We're going to use PGP, pretty good privacy. We'll back up everything from the root account. So we'll set up that user account. So we'll use this and that'll make us become root. So you see we've got a little hash prompt telling us we're now root. We're going to generate a random passphrase for encrypting the backup. So you just copy and paste that in. I've already done this. And then to make sure no one else can access this file, we'll change the permissions so that only root can read it and nobody else. We need to back up this passphrase on another computer in a safe location. Without this passphrase, you won't be able to decrypt the backups. This command will display it, so if you just copy and paste that in, it'll display on your console, and then please copy and paste that somewhere else safe so that in case you lose the password, you can restore the backup in the future. Now we need to get the exact path to this file and note it for later, so we'll use the real path command. So in my case, it's /root /.passphrase.txt. It'll probably be the same for you. Let's do a mock backup and restore to confirm the principles are correct. Change /root /passphrase to be the path of your passphrase file above, just in case yours is different. And change pdath Bitcoin backups to the name of the Amazon S3 bucket that you previously created. Copy and paste this all in one go. So basically we're going to use the tar command and we're going to create an archive of the /etc directory. Then we're going to run it into the pgp command, tell it to encrypt it with our passphrase using symmetric encryption, and output that to the next to the command line or the next thing in the pipe. And the last thing in the pipe is we're going to use the AWS3 command to copy it to our backup, to the S3 into that file. So we'll just copy and paste all of that. And that's busy doing the backup, and it's already finished. We can check that the file was created in the S3 bucket by using the ls command, and I'm just using human readable, so it formats it a bit more prettier for humans to read. So there is the file we backed up, and we can see it's 683 kilobytes. So we can do a test restore for this command. So we're going to use the S3 copy command to copy it from S3 back to, we're going to pipe it into the next command. Then we're going to use PGP to decrypt it. And then lastly, we're going to use the tar with the test command to test that the archive, backed up archive is valid. So we'll do all of that. And then that test command, it prints out every file in the archive that it's testing. Now we'll do an actual test restore to the temp directory. So it's almost the same as above, except at the very end, we're going to say tar and we're going to extract it to the temp directory. Because I don't want to overwrite the originals. We just create a temporary restore. So we'll copy and paste that in. You can see the backups are reasonably fast. And we can have a look at that restored directory using the ls command. So there'll be a temp directory, exec directory inside of temp. And that's our test restore done. So we'll do a bit of a cleanup. We'll remove that restored directory. We'll ask the S3 command to remove that file. And then we'll exit out of being the root user. So that's our new backup system all tested, ready for later deployment. Set up a VPN. Two popular VPN methods are WireGuard and Tailscale. WireGuard is built into the Linux kernel. It requires you to either have a static IP address or a dynamic DNS set up and to forward the WireGuard UDP port to your Ubuntu server. Another option is Tailscale. It actually uses WireGuard as a VPN, as its VPN protocol. Tailscale adds an orchestration layer, so you don't need a static IP address, dynamic DNS, or net forwarding. Tailscale is popular because it's free for personal use. In this guide, I will use WireGuard because I don't want to rely on any third parties. There are many guides for setting up Tailscale if you want something a little easier. WireGuard. Okay, we're going to set up the Ubuntu server side. So first of all, let's become the root user because we need to run many privileged commands. Then we can install the WireGuard service. So this will allow us to become root. So you can see how we change to the hash prompt to signify that. And then we'll install the WireGuard service. This is already installed for me, so it should hopefully be quite quick. Now we're going to change into the directory where all the WireGuard config files are. Now we're going to use the umask command because it lets you remove permissions from newly created files. And this will mean that only root will be able to access these files to protect them because they contain keys. Now, oops, I haven't done, you need to paste both of these commands in. Now, I've already got a working WireGuard config and I don't want to risk exposing my key, so I'm actually going to do this in the temp directory, but you do all of this in the WireGuard directory. Okay, the server will need a private and public key. So the gen key command creates our private key and the pub key option creates our public key. So we'll copy and paste those two in. and we look at those two files, so you can see they're only accessible via root. Now we're going to create some keys for our phone to be able to VPN in as well. So we're going to run exactly those same two commands, but this time we're going to create a file called phone private key and phone public key. So we can look at those files again. All right, so we can see they're all in there. For the server config file, we need the server's private key and the phone's public key. You can display both of these with, all right, so we'll paste that in. So this first line is the private key and the second one is the phone public key. We need to save both of these keys because we're about to use them shortly. I'm just going to put them in online notepad. When you do it, make sure you keep them local to your computer. It's just because I'm using Windows Sandbox and it doesn't come with any editors like Notepad. Now we need to create the etc WireGuard wg0.conf file using your favorite editor. This is used for the server end of the VPN. So I'm using VI, so I'm just going to go VI. So I'm doing this in my temp directory, but you'll be doing this in your etc WireGuard directory. And put this into the configuration file. Notice the post up and post down are each a single line. So these ones here, this is all one line, and that is all one line. And we got to put in the server's private key here, and the phone's public key has got to go here. And we need to replace all the references of ETH0 with the interface name your Ubuntu instance uses. So, and you can see that using like IP-4 ADDR. So if I just go back a bit, if I go IP, so we can see that that is my Ethernet interface here. Your machine could have a different name, so you need to note that name and update it. So I'm just going to go back here, copy and paste in this. And now I need to grab the server's public key. The server's private key. So that was the first line from here. So I'll grab this. So I'll put that in here. And this is the IP address that the WireGuard server will have for the VPN. So I'm assuming you're not using 10.0.0.0 in your network. Otherwise, you'll need to choose a new prefix. That's the port that it'll listen for WireGuard connections on. And just make sure this pasted all as one line, not two. So it's pasted in nicely for me. Now I've got to put in the phone's public key. So let's copy that here. All right, so that's that file all created. Next, we must make sure that IP forwarding is enabled. So you can turn on IP forwarding right now with this command. So we'll paste this in. But this doesn't stick across reboots. So we need to edit the etc ctl file. I'm going to use VI. You can use whatever you want. Or conveniently, I'm already on the right line, but you need to search for this line in the file. And then you got to remove the hash. So over here it starts with hash there. You just got to delete that hash so that the forwarding stays enabled for the next reboot. Okay, now we need to enable WireGuard to run on the next reboot. And we'll also tell it to start right now, so it's ready for us to use. Let's check that it began running and make sure that it says it's active. So we want to see that it says here that it's active, and we don't really want to see errors too much over here. Now you need to port forward UDP 51820 from your internet router to your Ubuntu server. If you're not sure, search online for instructions on how to do this for your Pacific router model. Okay, let's start on the setup for the phone now. We're going to generate a QR code for your phone to make setting up the WireGuard client a bit easier. We'll need the phone's private IP and the server's public IP. So we already created those files. So we're just going to display those two files on the screen. And we're just going to copy and paste those to Notepad like we did before. Whoops. Okay, so the first one is the phone's private key. And the second one is the phone's and the second one is the server's public key. Okay, so we're going to create a config file on the Ubuntu server, and once we've QR encoded it, this will actually be transferred to the phone for its configuration. And add this config to it. Add the keys from the above, and enter your router's public IP address where you configured the NAT. Make sure this file is as small as possible because we need to encode it into a QR code. So that's the phone's private key. That's the first line of this config. And then we've got to put your server's public key, which is the second line of that output. And then you've got to put whatever your public IP address, your public IP address here on your router. So let me copy and paste that in. Right, we'll go grab the phone's private key. And we'll put this in here. Whoops. And then we'll grab the server's public key. And we'll put this in here. You could also use a dynamic DNS name in here. I'm just going to pretend it's a static IP address. Let's pretend it's 1234. And then we'll save that off. This means when the phone's connected, it can access anything that's allowed IPs. You could narrow the scope a little bit if you wanted to. All right, we'll come back to here again. And now we're going to create a QR code. So this creates a QR code in the console. Now, the bigger this file is, the bigger this QR code is. So that's why you want to keep this file you've created as small as possible, because you can end up with this QR code actually being bigger than the screen. Now, before we install the WireGuard client, we need to install Zeus Wallet. Go to your favorite app store and install the Zeus Wallet. Make sure it says it's made by Atlas 21 Inc. and then we'll come back to setting this, up later. If we whip across to the Google Play Store, as an example, this is what it looks like. That's the icon, and make sure it says, here it is, made by Atlas 21 Inc. Once that is done, we can proceed to set up the mobile WireGuard VPN client. Search for install the WireGuard app from your app store. Make sure it says it's published by the WireGuard development team. So in the Google Play Store, that's what the icon looks like. Make sure it says it's made by the WireGuard development team. Another good sign is that it's got millions of downloads. Okay, I'm just going to switch across to the phone now. When you first run the client, it's going to give you an option to create a new tunnel. Because I already have one, I'm just going to have to use the plus button in my bottom right hand corner. And then we're going to use the option scan the QR code. So we're going to scan that QR code we created on the screen. And then you've got to give the tunnel a name. I call mine home. I've already got one called home, and so I'm going to call this one home 1. And then go create tunnel. Okay, so we've got our VPN created. We can go into there, and the next thing we'll do is we'll click the little pencil in the top right hand corner. Okay, once you've clicked the pencil symbol to edit it, come down to where it says all applications kind of in the middle here, and go include only on the top, and then we're going to select Zeus. Now because it begins with Z, it's at the very, very bottom, so we'll go all the way down there. Almost there. There we go. And now it says include one app. So we're going to click on that. So what this does is sets up the VPN so that it can only be used by the Zeus wallet on your phone. And because of that, you can just leave the VPN running permanently. So whenever you go into the Zeus wallet, it's just ready to go. So once you've done that, tap on the save icon at the top of the screen. And then the last step is to turn on the VPN. Now this won't work for me because I haven't actually set up the server side, but hopefully for you that'll turn on and you won't get any errors. Back on the computer, lastly, let's leave privilege mode on our Ubuntu server. So all we've got to do is type exit, so we can see we've got that little hash prompt, and we just type exit and we're back to being our standard user again. Finally, we've finished all the prerequisites and we can finally get around to starting the core Lightning setup. So I'm going to start doing with testnet 4. Bitcoin on testnet has no value. It's only used for testing. Testnet 4 is excellent to practice on. You can't lose anything of value on testnet 4. This section is optional, but if you set it up, you can practice using Lightning without risking real Bitcoin. Make sure you start this section with the initial account you used to log into your Ubuntu machine. You can use Ubuntu to check who you are logged in as. So if I go, who am I? My initial user is called Odroid. Yours might be Ubuntu or something else. If you're logged in with another account, you can use exit to return to that initial account. So if you'd used sudo or something like that, or su to get into it, become another user, you can usually use exit to pop back. So you need to start as your first logged in user. We need to retrieve the Bitcoin testnet for RPC username and password from the CK Pool solo setup we did in a prior video. The text below should be copied and pasted as a single command. You can also use the Bitcoin script share blah 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 to generate a new username or password if you want to just add it to your Bitcoin node. So I'm going to run this command. And it's asking for my SU1, so that is my username, RPC admin, and that is the password for my testnet 4 node for the RPC interface. You'll need to make a note of these and save them for later. Next, we'll create an account to run the Core Lightning testnet node, then switch to that account. So we're going to create a new user called CL for Core Lightning testnet, and join it to the testnet group. I've already got this account, so this will just produce an error for me, warning me they already exist. And now we're going to become that Core Lightning testnet user. Now we need to set up the Rust environment. So we're going to tell Rust to use the default stable train. We're going to be using a Python tool called UV. We will need to prepare a location for it to install its binaries into. We might as well create the standard local bin directory and the directory for storing the Lightning server config in one go. So -p means don't generate an error if the file already exists. So we're going to create .local/bin, and .lightning. So we'll set all these directories up ready to go. Now Core Lightning uses the Bitcoin CLI command. So we need to create a symlink for it in the Core CL testnet account. So you can just copy and paste that in. I've already got this, so this might give me an error for me, but that should work for you. We can now run the UV installer. So this literally downloads it and installs it into this isolated user account. Being an isolated user account, it can't touch the rest of the system. So that's already installed for me, so it didn't find anything to do. Okay, so several changes have been made to our login environment, and there's a couple of ways to activate them, but the really easy way is just to log out and back in again as this user. So I'm just going to type exit and go back one, and then log back in. And now all of those environment changes are applied. Now we are ready to clone the Core Lightning repository. So I've already got this cloned, so this will generate an error for me, I hope. It does. Yep, and now we'll change into that directory. We're now ready to begin building Core Lightning. So we're going to paste these commands in one at a time. And I just want to warn you, the Rust compiler is really slow, and this is going to take quite a while. You might think that maybe the process is hung even because just nothing appears to happen. I wouldn't worry unless it's I think it's going to take at least 10 minutes, but don't worry unless it's been at least half an hour. So this command here is not too bad. It just uses UV to get any components that are missing. So that's fast on my one. And this runs the configuration system. So it checks about all the stuff installed on your machine and what versions you've got and various build environments. Now this next command here, this is going to take a long time. So I'm going to start this running, and then I will come back when it's finished. Oh man, that took a long time. Now finally we can do the make install command. This one doesn't take as long, but it still takes a while. So I'm going to come back once it's already finished, because I've already installed it. All right, we can carry on. Next we need to create a config file. So we're going to create this .lightning config, and we're going to add all these lines below. Fill in the RPC username and password you stored from the beginning of the section. So that was back up That was from here. We got the RPC username and password. And we also need to specify that we're going to be using testnet 4, which is right there. Now, Alias lets you define a name for your node. You don't have to have one, but I like putting in like my name -testnet 4, and it can be up to 32 characters. I'd probably nothing with spaces, and I'd probably try and avoid using special characters most of the time. So I'm going to use VI and edit that file. Oh, I better copy that. So I've literally just copy and pasted all of that in. You can see where I've put the changed the name there, and that's where I've put in the RPC username and password, and we'll save that off. We can now start the Lightning server and test it out. So what we're looking for is it just start and run, and for there not to be any errors. So this is a good looking sign. We can now test that it's actually working. I guess I should point out that you must have a fully synced Bitcoin node before you can do this. It won't work properly. So we'll ask it to give us some info about the chain. Okay, that's a good start. So it's got some numbers here, and we're not in the middle of a block download. We'll now stop Lightning from running and exit back to privileged user mode. So we'll stop there, and we'll type exit. So now we're going to set up the daemon, and we want the daemon to run automatically when the system boots. So we're going to start our favorite editor and create a new systemd service. So we'll paste that in. And here's the contents to copy and paste in here. I'll just go through it quickly. Basically, you can just give it a name, whatever you want to call it. So we need a couple of things to happen before we can actually start this service. So we actually need our Bitcoin node to be online, and we need networking to be online. Otherwise, we can't do anything. And we also want to start it after the Bitcoin node and network are online. This says how to actually run the service. So we're going to run it as our limited user account in the testnet group, and it's just a simple executable. This creates an environment variable with a path so it can find all the executables it needs. This sets basically the current directory. When the service starts, it creates this thing called a PID file to identify the process ID, which systemd can use to track it. This says how to actually start it running, so it just runs that. How to stop it, so we use the Lightning CLI stop command like we did just up here. And this says we need to restart it, just give it a little pause. If it fails, always restart it running. And then these are things to reduce what it's allowed to access. Even though it's in a restricted account, this restricts what the restricted account can access even more, just in case it ever gets compromised. And this basically says when it should overall be started. Okay, so let's enable and start the new service. So we'll paste these commands in one at a time. So I've already pasted this all in. So whenever you change a systemd file, you got to tell it to do a daemon reload. Enable says run this next time the system reboots. Start says to run it right now, so that'll start it running. Status tells us if it's working or if there was an error. So hopefully there'll be no errors at this stage. So you really want to see it saying it's active and running, and no sort of real errors occurring down here. You can also look at the log using this command, especially if something's going wrong. But it's just saying here it's all loaded and started and everything's okay. Now we need to create a new on-chain testnet 4 wallet and fund it. So this is a real Bitcoin testnet 4 wallet. Once that is done, we can open a channel to fund it. So we're going to become our testnet user again. And then we're going to ask for a new address. So you can run this command as many times as you want. Every time you run it, you'll get a new Bitcoin testnet 4 address. Nearly always you're going to be using the Betch32 addresses these days. There's not really any reason to use the old ones. Now, if you have some testnet 4 Bitcoin, you can now send it to this address. Otherwise, you can use a faucet like this one here. So basically, you come over here and you copy and paste in your, without the speech marks, you copy and paste in your address. and then you say get Bitcoins. I won't do that because I've already got some money from this faucet. I want to make sure there's, not money, some testnet for Bitcoin, but I just want to make sure there's plenty available for other people. Now, also note the return address so that once you're finished with it, you can send the Bitcoin back again. Now, when you're creating Lightning channels, it's recommended that they're at least 0.01 BTC, which is 1 million sats. So you want to transfer slightly more than this to cover fees. Probably, if you're going to use the testnet for faucet, it'll just send a whole amount to you. Now, once you've transferred the testnet for Bitcoin, you can use the following command to verify receipt. So you can just go list funds. Now, often you're going to have to wait for 6 blocks for confirmation, and this is going to take a while. If Bitcoin's running nicely and it's doing a block every 10 minutes, it's going to be an hour. But sometimes blocks can take half an hour, sometimes they take less time. If we jump across to mempool.stats and we look at testnet 4, and then we can have a look at recent blocks. Wow, that's every now and then this happens. All the blocks are happening almost instantly at the moment, but so if you were doing this, it would happen almost straight away. So that one was 13 minutes ago. All right, so there's a 20-minute gap between those two. So the blocks are a little bit all over the place, but often you're going to have to wait at least an hour. When you're using the list funds, basically you want to see that the transaction you want to see that you've got something first of all. You might have a blank output to begin with. This is a bit to do with the transfer you just done, and you want it to have this confirmed status. Okay, so luckily I've already got that done, so I don't have to wait an hour. So the next thing is we're going to open up a channel on testnet 4. Now, compared to mainnet, this bit is quite painful. There aren't a lot of testnet 4 nodes you can connect to at the moment, so we're going to have to do something quite manual and look them up using DNS. So this command here will let us look up using DNS all of the current public testnet 4, all of the well-known public testnet 4 nodes. So we've got a 1, 2, 3, 4, 5, 6, 7. We've got 8 we can choose from at the moment. And each one of these is a node that we can potentially connect to. So the third number, that is the port. So they tend to be using either port 9735 or 49735. Note this down for later. So the field starting with an LN is the Lightning address seed name. So that's this bit here. So that is the Lightning address seed name. Testnet 4 nodes may be down, so we're going to use the NC command to verify our chosen node is up. You run this all as one node, and if this doesn't return succeeded, repeat the test with the following entry. So this will change all the time. So I'll do one based on my current screen output. So I'm going to ask it to connect to, and I'm going to copy and paste this entire DNS entry here, and then I've got to give it the port number here. Okay, that's good. So that node's currently up, so that's one we can use. If it's not up, then just go to the next node, keep going till you find one up. Usually you won't have to do many times. So you want to make a note of this entry here and just save that somewhere else so we can use that later. Now, a really painful bit. You don't have to do this on mainnet usually, but we often have to do this on testnet 4. We have to calculate the node ID from the DNS host name. So first we're going to change to the Lightning directory and start Python. Oops, it didn't paste in what I wanted. And now we'll run Python. All right, so we've got to copy and paste the below, and making sure to update the DNS name on the first line. So I'm going to say host, this is the one that we've tested and working. So this will change all the time. So I'm going to go up here, and that's the bit here. So we don't copy the test for anything else. We just copy that one entry just the host name. And now you can copy and paste all the rest in one go. Okay, so that has given us our node ID, which is that value there. So we're going to try and connect to that node and the IP address from before. So this will be different all the time. So I'm going to use the values on the screen. So I'm going to say I want to connect to that node ID. And then if I go back to my dig command somewhere, there we go. There's the IP address. And there's my port. So all going well, you should receive a JSON response containing details about your new channel. So it's all here. The next step is to fund the channel. So we're going to reuse the node ID from above. That's that one there. And we will fund it with 0.001 testnet for Bitcoin. If you've got less than that from the faucet, reduce the funding appropriately. So I'm going to go fund the channel. Now, I'm not sure I've actually got enough free testnet for money to do this. This might fail for me because every time I run this and connect to a different node, I get different answers. So I'm going to copy that node ID. And I'll get rid of the speech marks. Fund the channel. And I'll try and fund it with 100,000 sats. Okay, I don't think I have enough funds to fund another channel, but hopefully this will succeed for you at the moment. So you need to, if one node doesn't work, you could try pairing with another and doing it with that one as well. So you need to keep doing this. This is not normally a problem on mainnet because the nodes, you normally connect and pair with a specific node, whereas in testnet 4, you're trying to find anyone who's got their node up and running at the moment to connect. So you need to just pause and resolve any issues. We need at least one funded channel before we can do anything else. And if we run our list funds command again, oops. So before that was to do with the Bitcoin we received from the faucet, and now this relates to my funded channel. And once again, it can take up to 6 confirmations before the channel funding shows up properly under list funds, and we want to see it being channel normal, which is this piece here. So you could be looking at another, especially on mainnet, but you could be looking at another hour and a half for that to happen. Oh, I just remembered something. Do you remember before how I got this cannot estimate fees yet? I remembered I've had this problem before on testnet 4. And if you go into your Bitcoin core, or NOTs in my case, testnet directory, let's try that again. Who am I? That should be okay. Sudo NOTs testnet. What am I typing wrong? Sudo issue NOTs testnet, go into the .bitcoin directory and go into the testnet 4 directory. There is a file with fee estimate, and its name. There it is there. If you stop the testnet instance, delete this file, then start it again, it'll rebuild it. Maybe give it 10 or 20 minutes, and if you run that command to list the funds again, to fund the channel, it'll probably solve that error about not being able to do a fee estimate. This will make it start trying to calculate it again. This is not so much a problem with mainnet, more of an issue with testnet 4 and transactions being all over the place. To get Zeus Wallet to connect to our core Lightning node, we need it to trust it using certificates. So we've got to go through the painful process of setting up certificates now. So first of all, we're going to change into the testnet 4 directory. Now we'll configure a custom OpenSSL conf file, as the command lines will get pretty long soon. Create an OpenSSL-server.conf and add the below to it. Update the CN, which is that one there, and the IP.1 fields with the address of your machine. So if you're not sure, you can go IP-4ADDR, and that will show you the address of your machine. That'll need to be static. and copy and paste in that file. So I've already got that file, but I'll just open it up with VI. So you can see I've got all my contents pasted in, and I've updated my common name and the IP address. Now we can generate the server certificate and sign it with the CA certificate. First, we need to create a private key. You literally just copy and paste that one in. I don't want to overwrite my current private key, but when you run that, it will generate the key for you. And then you need to generate a public certificate. And you literally just copy and paste all of those files, all of that command line in. And then you can use the following commands to look at your certificate fields. So we'll paste that in. And so what we're seeing is it's been signed by the root CA that's already been set up by the Lightning daemon. And it's got the IP address loaded in as a alternate name. And where is the common name hiding? Oh, yeah, and here's the common name. So it's got all the right things on the field. So now we need to make this config active. So you just exit back to being your main account, and we just stop the Lightning daemon running, and then we start it running again, and will become our testnet 4 user account. All right, so that's our core Lightning testnet 4 node with a certificate that's been used that'll be trusted by our core Lightning wallet. Okay, now we got to think about backups again. Before we go any further, let's configure a backup to Amazon S3. Although this is testnet and we don't have any real Bitcoin to lose, it's good practice, because if this were real Bitcoin with a funded channel and you lost the data, you would lose real Bitcoin. So let's become the root user. Paste in the one at a time. It won't work if you paste both of these lines in at the same time. So we're just going to do an exit and then a sudo issue. So we're going to run these in the privileged root account so that nothing else can get access to the backups to either see them or download them, because they contain information that if others got hold of our backup, they could steal stuff from us. So we're going to create a script called backup-core lightning-testnet. So we'll just edit that one. With our favorite editor, I use VI, you might use Nano or something else. And you literally just copy and paste everything in. So this basically creates a tar archive. We exclude the Lightning RPC directory because we don't need that. And it backs up everything in .lightning. Otherwise, GPG, PGP or GNU PGP encrypts it. And then we just copy it to our Amazon S3 bucket. And then we start it again. So we got to stop the core Lightning node before we run this to make sure the database is in a clean state, and then we start it running again. Oh, the script stops core Lightning. We need to do this to put the SQLite database in a consistent state, safe for backup. Then we do the backup. Lastly, we restart core Lightning. Once you've saved the once you've saved the script, mark it as executable with this command. Whoops. Let me just exit out of that. So you'll mark it executable, and then just manually run the script once to verify everything is working. So that's good. We can see it copying the files. That's PGP encrypting it, and it's all done. And just to be sure, we're going to test the backup. So basically, we copy the data back out of S3, we decrypt it, and then use ask-tar to test the archive to make sure the backup's valid. So we can copy and paste that all in one go. So this will also show you each of the files that's backed up. So that's tested it, and it's good. And now we're going to schedule the backup to run weekly. If you use Lightning frequently, you might want to do this daily or more often. We're going to use cron to do this. So we'll go cron tab, edit. So this is my testnet backup here, and this causes it to do my backups at midnight every Sunday. So you can literally copy and paste in that line, and once you've done that, just exit out, and we'll get out of our privileged user account. Time to connect our Zeus wallet to testnet 4. So we're going to become the testnet 4 user again. Put in my password again. So we need to add the CA certificate to our phone, so our phone will trust our Lightning node. So Android requires the phone to have a CER extension, so we'll create a symlink to one. So we'll go into our testnet4 directory, and then we'll create a symlink from ca.pem to ca-testnet4.cer. I'm getting an error because I've already got the symlink, but that should work for you. We'll make this available via a temporary web server. So we need to get our machine's address first of all. So we'll do an IP-4 ADDR. So my main interface is Ethernet 0, and that's my machine's IP address. Then we're going to get Python to start a temporary web server, and that's going to be available on port 8080. So I'll just run that. Actually, what I'll do is I'll clear the screen, so when we come back to this later, we can have a quick look what appeared. On our phone, we'll start with, this is Android, of course, we'll start with a web browser. So we'll put in the IP address of our machine, and then we're running on, port 5050, so we'll put, port 8080, so we'll put that in next. And then we'll do a /, and that file was called ca-testnet4.cer. Whoops, I'll just read that, make sure I've got it all spelt right. Yep, I'll hit OK. So I've already downloaded this once, so you won't get this download file again. And then for me, it tells me it can't be downloaded securely. That means it can't be downloaded over HTTPS, but that's fine, it's all temporary. And then I'll just go keep. And then it warns me it can't install CA certificates from here, so we'll come back to that bit next. Let me scroll through the instructions. Okay, so from here, we got to go into settings, and then down to security and privacy. Where are you hiding? Oh, must have gone past it. Settings and privacy, where are you hiding? Security and privacy, there it is there. Then we're going to go to more security settings. All right, now we're going to scroll down to the credential storage section. This is it here. And we've got to say install from device, storage device. We're going to say we're going to install a CA certificate. Gives us a warning, this is a bad idea. We're going to say install anyway. It's making me authenticate. Now I get to navigate to it. It's showing me only the places where there are CA certificates, which is in my download folder. And the one I just downloaded was, it's ca-testnet4, so I just select that. And then I say done, and now it's installed. This is what it looks like back on the computer. A whole lot of mess. Usually somewhere in the log it shows the file you requested, but I can't spot that in here this time. All right, so we'll just hit Control-C to shut down that server. Okay, so now we're ready to generate a rune for the test wallet. So we'll say Lightning CLI create rune. Rune is kind of like a secret key between your wallet and Core Lightning. So that's our rune there. So we're going to use the following command to generate an on-screen QR code and change 192.168.82.50 for whatever the IP address to be on your server, and the rune E equals part from above. All right, so I'll copy that all in. And this time I have generated a different rune, so I'll put that in there. So I'll copy this rune in. Hit return. All right, so that's got us a QR code. All right, let's go back to Zeus Wallet. All right, let me generate that QR code. I just realized I made a bit of a boo-boo. I deleted this bit, so we need to keep that in. It's just the rune part that we got to replace. So I'll generate the QR code. All right, let's head over to Zeus Wallet. Okay, this is the first time you've started Zeus Wallet. You'll come up for a menu with a couple of options about creating a wallet. Choose the advanced setup, and then create or connect a wallet. If you've ran it previously, it'll come to a screen like this, and you can click on this little symbol in the top right hand corner to go to the wallet screens. Also, by the way, this is how you switch between the wallets. You click on that, and then you just choose the wallet you wish to use. So I'll go back to testnet4. Okay, so let's say we're going to add a new wallet. I click on the little plus symbol, and now in the top right corner, there's these two brackets things. If I click that, that's going to scan a QR code. So that's just scanned a QR code off the computer we generated before. I'm going to call this testnet 4, and maybe I'll call it ABC since I've already got one of these. All of the parameters will pretty much be correct. There's just one setting we've got to turn on down the bottom, which is the certificate verification. So once you do that, click on Save Wallet Config. Now, if you haven't got it right, you'll get an error right there. And if it gets to the screen, you've got it all configured correctly. Inbound liquidity on testnet 4. You now have everything you need to start using Lightning on testnet 4. However, you cannot receive Lightning unless you have inbound liquidity. How can you get that? Every time you send Lightning, you gain inbound liquidity. If you send 1,000 sats to someone, then you can receive 1,000 sats. That is fine if you want to use Lightning to spend Bitcoin. However, if it is a significant issue if you primarily want to receive payments, such as regular payments from a Bitcoin mining pool, or if you want to DCA buy regularly. As of the time I wrote this article, I cannot find any services that allow you to obtain inbound liquidity on testnet 4. On mainnet, you can get inbound liquidity by buying it from services like amboss.space/magma or from a swap service like bolts.exchange. All right, mainnet time. Now that we've done a practice run on testnet 4, it's time to do it again, but on mainnet and use real Bitcoin. I'm not going to quite show as many steps as I did on testnet because I don't want to expose as much information about my setup. So you'll have to refer back to testnet for a couple of the examples. Make sure you start this section with the initial account you used to log into your Ubuntu machine. You can use Who Am I to check who you're logged in as. If you're logged in with another account, you can use Exit to return to the initial account. So I'll go Who Am I? So I'm currently logged in as Core Lightning Testnet, so I'll just type Exit, and I'm now back to my starting account, which is Odroid for me. Might be something different for you. Now we need to retrieve the Bitcoin RPC username and password from the CK Pool Solo setup we did in a prior video. The text below should be copied and pasted as a single command. Note the results down for later. You can also use the Bitcoin script share auth RPC auth to generate a username or password. Note the results down for later. So we'll just copy and paste that in. Okay, so we've got, it's asking me just to authenticate. All right, so we've got the username and we've got the RPC password now. Next, we'll create an account to run the Core Lightning mainnet node and then switch to that account. So I've already done this once, so this will, I'll just get an error about this account already existing. And then we'll jump into that new account. So CL-mainnet, Core Lightning mainnet. We need to set up the Rust environment. So we'll just say we're going to use the stable chain. Okay, we'll be using a Python tool called UV. We need to prepare a location for it to install its binaries into. We might as well create the standard local bin directory and the directory for storing the Lightning server config all in one go. So we'll copy and paste our makedir command. Right, Core Lightning uses the Bitcoin CLI command, so we need to symlink that into the Core Lightning mainnet user account. So we'll symlink that in. And now we can run the UV installer. So it just downloads, runs. This is already installed on my system, so it'll be quite quick. Several changes have been made to our log environment, so let's log out and back in again to apply them. All right, now we're ready to clone the Core Lightning repository. So we'll copy and paste our git clone directory. Now I've already got this here, so it's just going to say it's already there. And we'll change into the Lightning directory. Right, we're ready to begin building Core Lightning. So we'll paste these command lines in one at a time. And just be warned, the Rust compiler is really slow. It's going to take a while. Sometimes it'll look like it might have frozen or hung because you get no output for such a long period of time. Give it at least half an hour if you feel that it might be in that case. So the first command, this is relatively quick. It just downloads all the components. Then we run the configure script, and it goes and figures out all the components on your machine and how different things are configured. This won't take too long. It's this next line here and the line after it that take a long time. So I'll start this running and then I will come back once it's finished. Okay, that's finished running. We'll do the make install command. Now this will take a while for you, but because I've already got it installed, hopefully it'll be quite quick for me. Yep, done. Right, now we need to create a config file in .lightning config and then add the lines below. You need to fill in the RPC username and password you stored from the beginning of this section, and the alias lets you define a name for your node. It can be up to 32 characters long, and that's an optional field. So I like to put in sort of a bit of my name and -mainnet so I can see what network it's on. Okay, so I've just copied and pasted that in, and just make sure you update the RPC username and password for whatever you're using. All right, let me quit out of here. Okay, we can now do a test start of the Lightning server. So we'll click on that and paste it in. Oh, mine's going to give an error because I've already got it running. All right, let me come back after I've stopped it. All right, let's try pasting that in again. All right, that's good. You want to see it start up and not have any errors. You also need a fully synced Bitcoin daemon before you run this. All right, we'll ask for some chain info. That'll help also verify everything can talk to what it needs. So we're on mainnet, so this is good. No initial block download. Okay, so that looks good. We can now stop the Lightning daemon from running and exit back to our privileged user account so we can set it up to start automatically. Okay, so we'll use your favorite, whatever your favorite editor is to create this CL-mainnet service. I'm just using VI. Once again, you might use Nano or something else. And then you want to copy and paste in all of this. So I went through this in testnet, so I won't really go much into it, but basically we're just saying we need all the NOT's mainnet to be running first. We set some paths, some security options, and then once you've done that, you can save it off. Whenever you change a systemd unit, you got to tell the daemon to do a reload. We're going to enable this service to run on boot. We're going to tell it to start running right now. We're going to check the status to make sure it actually did start running and hasn't got an error. We're going to see that it's in the status is active running, and we don't really want to see errors down here. And then we can just check the log if we want, especially if there's an error. You want to check the log, and everything's looking good there. Okay, we'll go back to being our mainnet user. Now it's all up and running. Now I'm not going to do some of these steps just to protect my own security, but they're going to be the same as mainnet. So first of all, we're going to ask it to generate a new Bitcoin address. Now you need to send some real Bitcoin from your wallet to this address. It is recommended that you don't open channels smaller than 0.01 BTC, which is 1 million sats. You'll want to transfer slightly more than this to cover fees. I'll give you an example of connecting to the NiceHash Lightning node, which has a relaxed limit of 0.005 BTC. You don't have to be a customer of NiceHash, do KYC, or have a NiceHash login to be able to connect to the Lightning node. A good starting amount to transfer might be 0.006 BTC or 600,000 sats. 0.005 BTC or 500,000 sats will be used to fund the channel, leaving us a little bit left over to pay fees. Once you've transferred the Bitcoin, use the commands below to verify receipt. So this is exactly like in mainnet. So once you transferred it, often you need 6 confirmations or 6 solved blocks. So this could easily take an hour, hour and a half. This is a good time to take an hour-long break. And just keep running the command above periodically until you see the Bitcoin appear. Once the Bitcoin's on your node, we need to open up a mainnet Lightning channel. You can use a service like 1ml.com, and that lets you search for nodes to potentially connect to. But in this example, we're going to use NiceHash because it accepts channels as small as 0.005, so it doesn't cost as much to get into it. You can find out information about the NiceHash Lightning node here. Most importantly, the bits that we really need are down here. All right, so let's try and connect to this. So in fact, you know that bit I just saw there? that goes at the end of the connect command. So you can just tell it to connect to the node. I'm already connected, so I don't think it's going to do very much. You should receive a JSON response containing details about your new channel. The next step is to fund the channel. You'll reuse the node ID from above, which is this bit here. That's the node ID. You can also see the node ID over here in the terminal without the speech marks. It's just the bit, just that bit there. Yep, so basically you say I want to fund the channel, and then that's the minimum 500,000 sats. So I'm not going to do this on screen, but that's how you do it. Make sure you don't get any errors. If you do, pause and resolve them first. Once funded, you can run the following command to verify everything. So this is just like we did in testnet 4. It can take up to 6 confirmations before the new channel funding shows up under list funds with a state of channel D normal. So that might take you an hour and a half, so be patient. Now, just like we had to create a certificate for Zeus Wallet to trust our core Lightning testnet node, we need to do the same for mainnet. So we're going to change into the Bitcoin directory under .lightning. That's where it stores the mainnet config. We'll configure a custom OpenSSL conf file, as the command lines will get pretty long soon. So we're going to create one called OpenSSL server-conf. Just do that using your favorite editor and paste in the below. So important bits to change is you need to change the CN to have the IP address of your node. And it also needs to go down here. Once you've pasted it in, save that off. We can now generate the service certificate and sign it with your CA certificate. First, we need to create a private key. Okay, so I'm not going to do this because I don't want to overwrite my certificate, but that will generate the server's private key. And then you can generate the public certificate, and you need to paste this all in one go. So this is one, copy and paste that, don't do it line by line. Once that's done, you can use this command to have a look at your new server certificate. So we're wanting to see that it's issued by the core Lightning root CA. It's got a common name with the IP address of your machine, and the subject alternate address has got the IP address listed. Okay, we now need to make this config active. So we're just going to exit out. We're going to stop the core light. The daemon, tell it to start running again. We'll check the status, and just in case it's unhappy with our certificate in some way. So it's saying active and running, that's good. And then we'll go back to being the mainnet user again. Backup of mainnet. Before we go any further, let's configure a backup to Amazon S3. If you don't do this and something happens to your machine, you could lose real Bitcoin. Let's become the root user. Paste these in one line at a time. It won't work if you paste them both in at the same time. So we'll exit back to our privileged account, and now we'll become root. Right, we're going to create a script called backup-cl for core Lightning-mainnet, and you just do that for your favorite editor. I'm going to use VI. You might use Nano or something else. And you copy and paste in the contents. So the script stops core Lightning. We need to do this to put the SQLite database into a consistent and safe state. Then we do the backup, and then we start core Lightning again. All right, so I've already got that in there. So we'll exit out. Once you've saved the script, mark it as executable, so we can just run it. And now we'll verify it works. We'll run a manual backup. So we can see PGP or GNU PGP doing the encryption at the moment. It's having a little think. Right. Now let's test the backup. So we'll copy the backup back to GNU PGP, and then we'll use the tar test command to verify that the backup is valid. That'll also verify all the files from the mainnet installation are being backed up. So mainnet stored in the Bitcoin directory, so that's a good sign. And finally, let's schedule the backup to run weekly. If you use Lightning frequently, you might want to do this daily or even more often. So we'll use cron to do this. So I'll go cron tab edit. Whoops. And I'm going to do my backups at midnight every Sunday. So that's the line to copy and paste in there. And you can see I've already got that copy and pasted in. Right, let's get back to being our standard privileged user. Okay, let's connect Zeus to mainnet. So we're going to become the mainnet user again. Now we need to add the CA certificate to our phone, and Android requires the phones to have a CER extension, so we'll create a symlink first. So first of all, we'll change into the mainnet Lightning directory, and then we'll create a symlink so that ca.pem can be accessed using ca-mainnet.ser. I've already done this, so I'll probably, it did it. For some reason I didn't have that file there. All right. We're going to make this available via temporary web server. So if you don't know the address of your machine, you can run that command, and that shows me the address we've got there. And then we're going to start a temporary web server using Python. Okay, I'm not going to show the screen recording section because I did that in testnet, but it's basically exactly the same. You just open up a web browser on your phone, and you browse to this magic URL. Obviously change that to be the IP address of your Ubuntu server, and that'll let you download the certificate. If you're on Android and the phone asks if you want to keep the file, click keep. If it warns you that the file must be installed via settings, then for a Samsung phone, go into settings, and then security and privacy, more security settings. So I've got a previous screen recording of this in testnet 4 if you want to see what it looks like on the phone. Then there's a section that's called credential storage, and under credential storage it says install from device storage. Select CA certificate. It'll ask you if you're really sure, and you say install anyway, and navigate to the location where the certificate is saved and click done. Now you can stop the mini web server with Control C. And now we can move on to generating a rune for Zeus Wallet. I won't show this bit because the rune is like a password, but basically you copy and paste that rune, that command into the CLI, and it's going to come up and it's going to generate, it'll tell you what the rune is on the screen. Use the following command to generate an on-screen QR code. Change 192.168.250 to be the IP address of your Ubuntu server, and then change this part here to be whatever your rune is. And when you run that, it'll produce a QR code on the screen. In fact, I can run that, it just won't be it'll make a valid QR code. Now start the Zeus wallet on your mobile. If you haven't yet created a wallet, then you'll select Advanced Setup and then Create or Connect to Wallet. Otherwise, click the round picture icon on the top right hand corner to show the wallets, and then click plus to add a wallet. In the top right hand corner, use the sort of square bracket option and select Scan QR code. Optionally specify a nickname for your node. I like calling mine after the chain, so this one I call mainnet. Then down the very bottom, turn on certificate validation and click Save Wallet Config. Zeus will then just check everything's correct, so hopefully you'll get no errors. If you get an error, you need to just go back and find out which step is wrong or been missed. Now you have everything you need to send Lightning on mainnet. However, you cannot receive Lightning unless you have inbound liquidity. How do you get that? Every time you send Lightning, you gain inbound liquidity. If you send 1,000 sats to someone, then you can receive 1,000 sats. That is fine if you want to use Lightning to spend Bitcoin. However, it is a significant issue if you primarily want to receive payments, such as regular payments from a Bitcoin mining pool, or if you want to DCA buy regularly. You can purchase inbound liquidity from services like amboss.space or a swap service like bolts.exchange. Right, if you've got this far, you've done very well. That was quite a long and complex setup. So I hope that video helped you along on becoming a self-hosted core Lightning user. And if you have any questions, just leave them in the comments below. Thanks for watching.